Very good morning, students. So today the index numbers 10 mark problems we are going to discuss. Yesterday anyhow we have seen two problems based on weighted aggregative methods. They are like last payers to Fisher's calculation in terms of price index or in terms of quantity index number. At the same time, if value or expenditure is given in the question rather than giving quantities or prices, so you know that expenditure is nothing but price into quantity. At the same time, value is nothing but price into quantity, right? So if expenditure or values are given, so how we have to calculate, yesterday we have seen. Now today I would like to discuss how to verify Marshall-Edgeworth's and Fisher's satisfying TRT as well as FRT. Okay, so as you all know that Marshall-Edgeworth and Fisher satisfies TRT. At the same time, Kelly also satisfies TRT, and only Fisher's satisfy FRT, right? So first and foremost, let us see this question. Just look at the board now, everybody. Verify whether Marshall-Edgeworth's and Fisher's satisfy only TRT. The question is asked only for TRT. TRT refers time reversal test, the reciprocal of time periods, isn't it? Look at the problem now. Items A, B, C, D and the base. Under the base they have given price and quantity, and under the current they have given price and quantity. So it's a straight question, right? So there is no expenditure or value here. Just straight question, price quantity, and price quantity they have given under base and current. Now under the base you know that price and quantity are nothing but P0 and Q0 notations, and under the current you know that P1 and Q1. And then soon after taking the table, every time we need to calculate the four columns: P1 Q1, P0 Q0, P1 Q0, P0 Q1, 1 1 0 0, 1 0 0 1. I mean 1 1 0 0, 1 0 0 1. This way the code. I told you to easily remember the code. 1 1 0 0, 1 0 0 1. This way. And then by multiplying each other according to the column, P1 Q1 means just current P1 and current Q1 both should be multiplied. 50 into 3, 30 into 3, 30 into 8, 100 into 6. Find out the total first, the column total P1 Q1, and then P0 Q0, base both price and quantities under base both should be multiplied. 40 into 2, 20 into 3, 30 into 6, 80 into 5, this way. And then P1 Q0, price in current multiplied by base in quantity. So 50 into 2, 30 into 3, 30 into 6, 100 into 5. And then P0 Q1. P0 Q1 means base in price multiplied by current quantity. 40 into 3, 20 into 3, 30 into 8, 80 into 6. After calculating all these four, we need to find out the totals. All the four column totals we need, because we have to substitute all these totals in the given formulae. Just see there. Question what it is asked? We have to satisfy Marshall-Edgeworth's as well as Fisher's in TRT, time reversal test. So let us see that now. So Marshall-Edgeworth, as you all know that, what is the formula for Marshall-Edgeworth? P01 ME equals to summation P1 Q0 plus summation P1 Q1 divided by summation P0 Q0 plus summation P0 Q1. At the same time, time reversal for this, that means P10. So wherever the 0 you put 1, wherever the 1 you put 0 from the original formula. Just see there, time reversal. There in P01, P1 Q0 it is there. So when it comes to P10, in place of P1 P0 will come, in place of Q0 Q1 will come. So the same way time reversal you do it. So P10 equals to summation P0 Q1 plus summation P0 Q0. Look at the original formula and then write the time reversal. Just interchange. And summation P1 Q1 plus summation P1 Q0. That is the reversal Marshall-Edgeworth formula. P1 naught equals to summation P naught Q1 plus summation P naught Q naught divided by summation P1 Q1 plus summation P1 Q naught. As you all know that the adequacy of test for adequacy in index numbers, 100 we need not multiply. 100 when you have to use when we want to compare the price level and base quantity level or the value level. So there it is expressed in terms of percentages, but here we are testing it, we are proving it, the TRT and FRT. So we need not multiply by 100 here, because here we are not observing how much it is increased or decreased, just we are observing whether time reversal satisfies the below condition or not. What is the condition given? P01 into P10 equals to 1. So ultimately by multiplying both P01 into P10, the value should be equals to 1. Just see there. Take both Marshall-Edgeworth condition P01 into P10. So both the formula I have written at the right side corner on top. Just see there. After taking the formula, you have to substitute the numericals in the place of the written formula above. Clear? So substitute all the totals, whatever the total we calculated in the columns, tables. So all those totals accordingly you have to substitute there. After substituting all the values, definitely you might observe the numerator and denominator gets cancelled. Just you can cross check. Okay, after totaling also you can do, or else just by substituting numerator denominator and again denominator numerator both crossway diagonally we can cancel it. Just look at there. P1 Q1, P1 Q0. Even the reversal denominator you see. First non-reversal numerator P1 Q0 plus P1 Q1, and reversal denominator is P1 Q1 plus P1 Q0, almost both one and the same. So after substituting the values, you will get cancelled. Those two values gets cancelled, and obviously the value will become 1. As you all know that Marshall-Edgeworth satisfies TRT, time reversal test. Now coming to the Fisher's. As you all know that Fisher's, it's a geometric mean of last payers and past years. You know the formula, right? So geometric mean of last payers and past years. Just by substituting the formula in the place of time reversal condition P01 into P10. Just look at the formula there. Summation P1 Q0 by P0 Q0 into summation P1 Q1 by summation P0 Q1 multiplied by time reversal now P10. In the Fisher's you have to apply time reversal. P01 Q1 by P1 Q1 into P0 Q0 by P1 Q0. Here also the same way, numerator and denominator, the common elements gets cancelled. So under the root, all the values gets cancelled. Under root 1 is nothing but 1. So again, Fisher's index satisfies TRT, time reversal test. Just look at once again. First and foremost, you need to identify the notations. After placing the notations, according to the formula given, you need to find out the column totals. What are the 4 columns? They are common for every problem. Remember guys, whenever the last payers to Fisher's, any method if they ask, all these 4 totals are very much needed. Clear? If at all only last payers it is asked, just only 2 columns are needed, that is P1 Q0 and P0 Q0. If at all it is asked past chase, P1 Q1, P0 Q1. But all together if it is asked, Marshall, Fisher's, Dorbish, Bowley or anything, you need to calculate all the 4 totals. And then apply in Marshall-Edgeworth formula, original formula as well as the time reversal formula. Both has to be written. And then as you all know the condition TRT is P01 into P10 equals to 1. This is the condition for TRT, time reversal test. And then after substituting the values, the totals, the column totals which are P1 Q1, P0 Q0, P1 Q0, P0 Q1, all these 4 totals, after substituting in that formula, definitely the numerator and denominator of both the reversal as well as non-reversal ones gets cancelled. Ultimately you will be getting 1 after getting cancelled by numerator and denominator, all the values. One thing is that verifying means just don't write the formula and directly show 1. You do not do that. Okay, you are not supposed to do that, remember. So what you have to do is, after taking the formula, applying the condition of TRT, okay, you need to substitute the values and prove that it is equals to 1. You are not supposed to write what I have written on the board. Okay, so because totals I have not done, that is the reason what I have made the statement there, substitution of all the totals. Okay, so you have to substitute the values, the totals, and then prove that it is equals to 1, the TRT condition. Then you need to write the conclusion that Marshall-Edgeworth satisfies TRT. At the same time, similarly, the Fisher's index numbers also. You all know that Marshall and Fisher's both satisfies time reversal test. So even that Fisher's formula P01F equals to, you know that the geometric mean of last pairs and pairs, that is square root of product of last pairs into pairs, last pairs and pairs. Okay, so after writing that, again time reversal, that's why continually I have taken the root. Just see there, first last pairs into pairs I have written, again multiplied by last pairs into pairs, time reversal I have written. That's it. Now again the same method, after substituting all the totals in the required given formula, your answer should be equals to 1. Here also the same thing I am saying. After writing the formula, you are supposed to substitute all the totals and then prove that it is equals to 1. Okay, just don't blindly write the formula and then cancelling all and equals to 1. You don't make it out like that. After substituting only, you have to verify whether this problem satisfies TRT or FRT in Marshall and then in Fisher's. Are you clear? So last pairs, pairs, Dorbish-Bowlett do not satisfy any test. You all know that. Only Marshall-Edgeworth and Fisher satisfies TRT. Even Kelly satisfies TRT. And Fisher satisfied by one and only method, that is FRT, factor reversal test. So remember that. So this is the problem. Now let us see the same problem, how Fisher satisfies FRT, factor reversal test. Time reversal means the time points you have interchanged, not 1 to 1 not. Now factor reversal means time should not be interchanged. Here you have to interchange the factors like price into quantity should be equals to value index number V01. So let us see that problem now. Now look at this problem. Verify whether Fisher satisfies FRT, factor reversal test. So here also once again the 4 columns are required and those totals are required. After that, what is FRT condition? P01 into Q01 equals to V01, value index number. The price into quantity equals to value. That is what the factor reversal we have to prove now. So first thing, the Fisher's formula you write down summation P1 Q0 by summation P0 Q0 multiplied by summation P1 Q1 by summation P0 Q1 under the square root, that is P01 F. Now multiplied by quantity Fisher's. So quantity index number in Fisher's, that you need to write square root of summation Q1 P0 by summation Q0 P0 multiplied by summation Q1 P1 by summation Q0 P1. So after all substituting all the totals from the columns which you have calculated, so definitely you will be getting P1 Q1 whole square and total P0 Q0 whole square under the square root. So squares roots gets cancelled. So what you need to do now? Ultimately you will retain summation P1 Q1 total divided by summation P0 Q0 total. That is nothing but value index number V01. So this is one more problem. I think I am clear. Fisher's and Marshall-Edgeworth. Marshall-Edgeworth satisfies TRT. Fisher satisfies both TRT as well as FRT. But whenever the problem is given and asked to prove, you have to substitute the totals and prove that the condition as per the formula. As per the condition. Clear? So without substituting the values, don't write directly the value, I mean V01 like, and then in TRT equals to 1 that way. After substituting the totals, then only it has to be proven that the condition satisfies TRT as well as FRT. Clear? So this is the problem. Now let us see the next way of solving the problem is, so I think all the 10 mark problems are over. Even in these cases also sometimes expenditures will be given or value will be given, remember. Okay, value or expenditures, anything will be given, right? So always when you are finding or when you are proving these tests TRT and FRT, 100 need not be multiplied, remember this. Okay, 100 need not be multiplied for all these verifying the test TRT, FRT, circular, whatever it is. Clear? So now let us see the next problem. Look at the next problem now. So almost all the 10 mark problems we have completed. I think those are only the 10 mark questions. Now coming to 5 mark problems. Calculate unweighted arithmetic mean and unweighted geometric mean. As you all know that unweighted quantities will not be there, right? Only prices, because weights are not considered. These are simple aggregative, simple average of price relatives, these both, right? So unweighted is nothing but simple arithmetic mean. Unweighted geometric mean is a simple geometric mean. Now look at the data given. Items A, B, C, D, E, and then prices in 2010, prices in 2012. So one is base P0 and another one is current P1. Those values are given. Now here what you need to do, first and foremost, P has to be calculated. So here the P is nothing but price relative, the ratio of current year price by base year price, which is expressed in terms of percentages. So P1 by P0 into 100. So individually it has to be calculated. That is P1 29 divided by P0 26 multiplied by 100. That is the first value of item A, P. And then for item B, 40 divided by 42 into 100. Write that value. Next 24 divided by 20 into 100, and then 16 divided by 16 into 100, 60 divided by 50 into 100. So here you need to calculate the price relative P1 by P0 into 100, remember. So after calculating all those, you need to find out the total P, because for calculating the unweighted arithmetic mean, the formula is, look at that, summation P by N. This is the formula given for unweighted arithmetic mean, summation P by N, where P is nothing but price relative, that is P1 by P0 into 100, and N will be the number of observations or items. So and then after calculating the P, you need to calculate total sum of P, and then divided by N, you will be getting arithmetic mean, AM. And then the geometric mean formula, anti-log of summation log P by N. First learn writing the formula first, because formula for every problem, formula carries 1 mark, remember. So every problem has its weightage in writing the formula. So according to that formula, P we have calculated already, but we need log P in geometric mean. So you all know that how to calculate log P, either from your scientific calc or just by referring the log tables also can be written. Okay, so calculate log P, preferably scientific calc for making quick calculations. So log P calculations you do, all individual P value, whatever the answer you get in the column, that log P individually you have to calculate and total the log P. Sum of log P you need to calculate. So after calculating that, substitute in the given formula, which is geometric mean, anti-log of summation log P by N. First, within the bracket term you complete it, that is summation log P by number of observations 5. You will be getting one value. Now anti-log of that value, how to calculate from your scientific calc? I have written, see there, shift log and then the value. Shift log will become anti-log. Remember from your scientific calc, the first key shift and then the log button if you press, that is nothing but anti-log, and then the value, which value, summation log p by n, what value you get, that value you substitute, shift log and that value, the answer will be getting geometric mean. Is it clear everybody? So unweighted arithmetic and unweighted geometric mean, this is how you need to calculate it. First step is like identifying the notations, every problem. Step number 2 is, according to the question, first write the formula at the left side or the bottom of the table. After writing the formula, in the formula what requirements were there, what are the things needed. So there in arithmetic mean P is needed. So where P is nothing but price relative, P1 by P0 into 100. So P1 values are given and P0 values are given. Substitute there directly, P1 by P0 into 100 individually. Right? After substituting and then calculating the P, you need to calculate total of P. So that total P, sum of P can be substituted in the formula, known formula, that is arithmetic mean equals to summation P by n, where P is nothing but price relative, that is P1 by P0 into 100, and n is nothing but number of values or number of observations, items. So and then geometric mean also the same way. For the geometric mean formula, anti-log, n is there and then P is there, but log P we need it. So one more column you make it, which is log P. Then after calculating the P, log P, individually the log values you apply and find out the total of log P. And then substitute in the known formula, that is anti-log of summation log P by n. First you complete within the bracket term, log P by n. So you get one term, one value. Afterwards, anti-log of that value, how to do it from your scientific calci? Shift log if you press, that becomes anti-log. Remember, shift log becomes anti-log, and then the value, calculated value, summation log P by n value you have to substitute. So shift log of that value will be getting geometric mean value. So remember, whenever you calculate arithmetic mean and geometric mean, one thing you observe carefully, arithmetic mean value will always be greater than geometric mean, because AM has greater weightage. Each and every item will be considered. Each and every item will have a greater weightage, equal importance. But wherein geometric mean, if any negative term is there, definitely it cannot be calculated, or any zero is there, it cannot be calculated. Right? So remember, geometric mean is used for finding the rates and ratios. Arithmetic mean is a most commonly used, which considers all the items are equal. So unweighted in the sense what? Every observation has an equal importance. Okay, there is no bifurcation, which item, how much quantity, like that. So all the items are in equal condition, remember. So that's why arithmetic mean gives the greater weightage to the items. That's why arithmetic mean value, any problem you calculate, AM and GM, whether it is unweighted or weighted, AM value will always be greater than GM value. Okay, so GM will always be less than AM value. I think this is 1 mark question. Why arithmetic mean is greater than geometric mean? So this one question will be asked. Why arithmetic mean is greater than geometric mean? What do you need to write here? Arithmetic mean gives greater weightage to bigger items, so that the arithmetic mean would be higher than the index numbers using geometric mean. Okay, AM gives the greater weightage to bigger items. Am I clear? So this is the unweighted arithmetic and unweighted geometric mean. Same thing for weighted arithmetic mean and weighted geometric mean we shall see. Now look at this problem. Calculate weighted arithmetic mean and weighted geometric mean. So here also the same way, prices under base and prices under current values will be given. P0 and P1, and weights will be given because it is a weighted averages. So that's why weights will be given. Let us consider that is W. And same process, as you all know how to calculate unweighted, there only one missing term is weights, that's it. Okay, so here as you all know that P has to be calculated, which is price relative, P1 by P0 into 100. So individually you calculate the P, and afterwards according to the arithmetic mean formula. What is that formula now? Summation WP by summation W. Okay, where W are nothing but weights which are given directly. P is nothing but price relative. So price relative you have to calculate it by solving, by substituting P1 divided by P0 multiplied by 100. So you will be getting all price relative values. Afterwards just multiply W and P. So multiply the weight W and the P what you have calculated, price relative, and then find out the total of summation WP, and then substitute in the arithmetic mean formula, summation WP by summation W. At the same time, geometric mean, anti-log of summation W log P by summation W. So here also the weights are known. P we have calculated already. For the arithmetic mean what price relative we calculated, the same P, and we need log of P. So again one more column you make it, log P. So P price relative and log P, individually you calculate log of P. After calculating all the terms log P, either by using scientific calculator or by referring the log tables, preferably scientific calci, because scientific calci can be used in the final examination also, scientific and normal calci, only in case of statistics subject. Remember this, only in the subject statistics you can use scientific calci. Even in the board examination you are allowed to use scientific calci, remember that. So after calculating log of P, so for the formula we need W log P total. So W we have weights and log P we have calculated just, and then multiply both again, W into log P. After multiplying each value in the row, you have to calculate summation of W log P. So what all totals are required now? Summation W is a common total required, WP total and summation W log P total. Only in between these log P you have to calculate after finding the price relatives P. So substitute the values summation WP by summation W in arithmetic mean, and then anti-log of summation W log P by summation W. First within the bracket term you complete it initially. Summation W log P by summation W. If you do it, you will be getting one value. So that means anti-log of so and so value. You will be getting it. Now you know how to calculate anti-log. Once again, take the scientific calci. Shift log and the value. Summation WP by summation W. What value you get? No, that one. And then you will be getting the answer of geometric mean. Clear? So once again here, arithmetic mean will always be greater than geometric mean. Remember, suppose if you have gone wrong in calculation, somewhere the arithmetic value comes low than the geometric mean, then obviously your calculations are wrong. As you all know that arithmetic mean gives greater weightage to bigger items, right? So geometric mean will not. Precisely, even the decimal and even the negative or even the zero will not be considered in geometric mean, right? So but wherein arithmetic mean commonly, equally, like all the items, for the bigger items it gives greater weightage. That's the reason arithmetic mean will never be less than of geometric mean. It is always greater than of geometric mean. But in terms of conditions or the limitations, geometric mean is the best average of finding an index number, because it gives the accurate value as well as the precise value. At the same time we are dealing with ratios in index numbers. So for ratios and all, geometric mean is the best way of finding any index number. So that's the reason geometric mean is always the best average of finding index number, and arithmetic mean is the most commonly used average. But when we compare both AM and GM, AM value will always be greater than GM value, geometric mean, right? So with this, I am going to wind up this video. So I hope today two methods we have calculated. One is like TRT, FRT proving in Marshall-Edgeworth as well as Fisher's. Marshall satisfies only TRT, Fisher satisfies both TRT and FRT, remember. That's why Fisher's index number called as an ideal index number. Next one is like weighted and unweighted arithmetic mean and geometric mean. Just observe, unweighted means there will be no weights, no quantities, no units, nothing of that sort. Okay, so weighted means definitely the weights will be assigned, given. So this is the problem. Now I hope this video is very clear. Kindly follow the videos and prepare well for the examination. All the best for your exams. Thank you. Have a nice day.